So hi everyone, welcome to Raaonline. This is Dr. Srivatsan, your faculty for biochemistry. Okay, and in today's session, this will be the part 2 session of your translation. Okay, so in part 1 session, we have seen what are the various kinds of requirements for translation. Okay, what do you mean by translation? Translation is nothing but synthesis of protein or protein synthesis. Okay, so from the central dogma of molecular biology, what you get, like from DNA you get RNA, so that is called as transcription, and from transcription you are getting the protein, so that is called as translation. So what were the requirements, what are the prerequisites for translation? Do you remember? The prerequisites for translation were your first mRNA, okay, that is your base from which it has got the codons from which your amino acids will be arranged. So you have got an adapter molecule, which is nothing but your tRNA. As I told you before, this adapter molecule is just to translate the genetic code to that of the protein language. So this is the function of tRNA. Then all this takes place in some kind of an office. So this office kind of a structure is called as ribosomal RNA or RNA. So we have got all these three. Then we have got amino acids. Amino acids are the primary requisites, because from the amino acids you are going to make the proteins, right? So obviously you will be requiring amino acids. And finally, since you are arranging all these things together, you are bringing all these things together, you need to have lots and lots of volunteers there, and this kind of volunteer function will be done by what? Will be done by various kinds of translation factors. Okay, so these translation factors can be named according to the place in which it helps. Okay, so it can help during initiation process. They are called as initiation factors. If they does its function during the elongation process, they are called as elongation factors. And if it is doing its function during the termination of this translation, they are called as termination factors, or otherwise effectively called as release factors, because you are effectively releasing the protein effectively after translation. Okay, so these are called as release factors. Okay, now this is common prerequisite for both prokaryotes as well as in eukaryotic cell during translation. Now, what was the first step? Do you remember what was the first step in translation? The first step in translation is to charge your tRNA. So how do you charge your tRNA? You need to attach that tRNA to that specific amino acid. So tRNA has got this DHU arm, which is dihydrouridine arm, which is through this arm the tRNA will try to understand what kind of amino acid tRNA synthase is there, what kind of amino acid RNA synthase is there, and it is through this it tries to understand what kind of amino acid it can attach. Okay, so this attachment of amino acid to that of the tRNA is called as charging up of tRNA. So before you charge your tRNA, you need to activate your amino acids. So this activation of amino acid is what? You are taking the amino acid from the amino acid pool and you are just attaching the enzyme to that amino acid tRNA. With the help of that enzyme, you attach a what? That tail. Okay, that kind of an amino acid is called as an activated amino acid. Okay, so it is through this the tRNA, dihydrouridine arm of tRNA will try to recognize this amino acid, and this amino acid will go and sit on the 3' region of the tRNA according to the anticodon which is present there to that tRNA. So till this it is common for both prokaryotes as well as in eukaryotes. Now we move on into the proper topic of translation, and in this session we will be seeing about translation especially in prokaryotes. There are some minor differences between a translation occurring in prokaryote as well as a translation which occur in eukaryotes. The process are the same, but the factors will differ. Clear? So there are the three main processes which are involved during translation of prokaryotes. They are initiation, elongation and termination. You all know this. So, initiation is starting of translation, elongation is the propagation and the chain formation, and termination is the release effectively of that protein which is being formed. Clear? Now, we will see what are the occurrences which occur during initiation. So, initiation, the first thing, if you are arranging some kind of a function, you need to first what do? You need to arrange that building, right? So, this kind of a building, this kind of an office kind of a thing is the ribosome. Okay. So, the ribosomes actually has to get altered in order to accommodate all the occurrences which is going to happen inside. So, this you call it as ribosomal dissociation. In case of prokaryotes, the ribosomes will be 70S ribosomes, as I told you before, and in case of eukaryotes, it is 80S ribosomes. The components I have explained that in detail in the part 1 of my lecture of translation. You can go through that. Now, this 70S ribosome will get acted upon by a factor called as initiation factor 6. Upon acting of this initiation factor 6, see, this topic has huge number of numbers and it does not follow any kind of a concept. Okay, even though it is loosely based on a concept, it does not needs to be memorized. So, please follow carefully what I say. It's easy to understand. It's extremely easy to even reproduce the thing. Clear? So, the 70S ribosome has to get broken up, dissociate. So, how the dissociation of 70S ribosome will take place? The dissociation will be done by initiation factor 6. So, it all starts with 6. So, IF6 breaks open this 70S into two parts. The larger part is 50S ribosomal unit and the smaller part is 30S ribosomal unit.